Let's solve the following linear inequality. So this is a linear inequation. That's because we have an inequality sign less than or equal to involved here, and linear because the highest power of x is 1. So let's begin. So what we'll do, we'll consider the LCM of 5 and 7. So that's going to be 35, and we'll multiply each side with 35. So we have 35 times 2 multiplied to x minus 1 divided by 5. So this is less than or equals to 35 times 3 multiplied to x plus 2 divided by 7. So here 35 is a positive number, so that's why multiplying both sides with positive 35 didn't affect the sign of the inequality. We have to be very careful about it whenever we are multiplying or dividing with any number. So 5 times 7 is 35, so we have 7 times 2, so that will be 14 multiplied to x minus 1, so this is less than or equals to 7 times 5 is 35, so 5 times 3 will be 15 multiplied to x plus 2. Let's distribute 14 with x minus 1 to get 14x minus 14, and we distribute 15 with x plus 2 to get 15x plus 30. What we'll do, we'll take this negative 14 and transpose it to the right hand side, so this will give us 15x plus 30 plus 14. So that means we have 14x is less than or equals to 15x plus 30 plus 14 is 44. And we'll transpose 15x from the right hand side to the left hand side. So we have 14x minus 15x. So this is less than or equals to 44. So 14x minus 15x, so that's negative x less than or equals to 44. Now we need x. So we have a negative x. To get rid of the negative x, what we'll do, we'll multiply both sides with negative 1. So we have x and negative 44 on the right hand side, but on multiplying with a negative number, the sign of the inequality flips. That means we will now have greater than or equals to. So x is going to be greater than or equals to 44. This is going to be the solution to a given linear inequation. We can also represent this on a real number line. So we'll consider 0 and negative 44 here. So we have to consider all the values of x which is greater than negative 44. That means lying to the right of negative 44. And negative 44 is included, so we'll use a dot at x equals to negative 44. And now the way of representing the solution is in the interval form, which is also referred to as the solution set. So we have our solution running from negative 44 all the way up to positive infinity. The positive infinity is an unbounded, so it will be denoted by an open interval, and negative 44, so here we have to include it because it's part of the solution, so we'll use a closed interval. So these are the 3 different ways of representing the solution to a given linear inequality.